Hello everyone. Today we are going to look at Quadrature Phase Shift Keying or QPSK using this virtual laboratory. QPSK is a digital modulation technique used in communication systems to send data efficiently. The aim of the experiment is to understand how a stream of binary data is converted into two signals called the in-phase component and the quadrature component. These two signals are used to change the phase of the carrier signal, allowing two bits to be transmitted in a single symbol. In QPSK, binary data is grouped into pair of bits called dibits. There are four possible combinations, that is 00, 01, 10 and 11. Each pair of bits correspond to a different phase angle of the carrier signal. These phases are 45 degree, 135 degree, 225 degree and 315 degrees. To generate these phases, the system splits the input data into I and Q signals. The I signal modulates a cosine carrier while the Q signal modulates a sine carrier. Because these two carriers are 90 degree apart, they can transmit information independently. The procedure begins by activating the transmitter blocks in sequence. Then we enter an 8-bit binary sequence as the input signal. Next, we set the carrier frequency and signal amplitude. After configuring these parameters, the system generates the QPSK waveform. In the simulation section, the QPSK transmitter is represented using functional blocks. To begin the experiment, we must activate the blocks in the correct signal flow order. First, we click binary input, then I and Q bit splitter, followed by the QPSK modulator, and finally the oscilloscope. After clicking these blocks in sequence, the virtual lab interface becomes available. For this experiment, we enter the binary sequence 11001010 in the bits field. Next, we set the carrier frequency to 2 Hz and then the signal amplitude to 2 volts. Channel 1 shows the input binary signal. Channel 2 displays the in-phase and quadrature components. Channel 3 shows the carrier signals and Channel 4 displays the final QPSK modulated waveform. The results section shows the relationship between the input bits, the I and Q components and the resulting carrier phase. This experiment demonstrates how QPSK transmits 2 bits per symbol by changing the phase of a carrier signal, making it an efficient technique used in many modern communication systems.